Hi, Dr. B here, and let's take a look at the periodic table in terms of how it follows the electron configuration for the electrons in any atom. Put it another way, aufbau order is a powerful tool, and by that we mean that where the electrons are in an atom determines their chemical behavior. So it's really something you shouldn't be underestimating. It's at the heart of all chemical behavior. It's at the heart of chemistry. And as they fill up around a nucleus, they do so in a very predictable behavior, and we call that the aufbau order, starting from the very first shell and working its way out to the seventh shell for some of the most recently discovered elements. And if future elements continue to be discovered, and I'm sure they will, it'll apply to the eighth, the ninth, 10th shell. The beautiful thing is it follows a symmetrical pattern. And that pattern is really a system of patterns within patterns. Since it's responsible for all chemical behavior, the periodic table is designed to reflect that. We have the first shell. That's the first row in the periodic table. It consists of an s orbital, and that's it. 2 electrons, so that first row is the 1s2 electron configuration. Continuing with the aufbau order, we go to the second shell. And notice that we're just reading the periodic table like a book. We have the 1s subshell here, and this entire group here would be the S block. This region is the P block, this is the D block, and this is the F block. But let's just read it like a book. 1s2, fine. 2s2, that's the electron configuration out to beryllium. And let's go into the P orbital group here. So this would be P sub x, P sub y, and P sub z of equal energy. And that is 2p6. The electron configuration of neon is 1s2, 2s2, 2p6. Let's continue to the third shell, 3s2. Continue to read it like a book. Notice these little reminders here. Going out to argon, we're now at 3p6. Reading it like a book, continuing. Fourth shell now, 4s2. But we now find a new pattern kicking in. The 3d orbital group now kicks in, and it's not a 8-electron system, it's a 10-electron system. 3d10 brings us out to that part of the D block. We go back to the fourth shell, and we now are at 4p6. Notice that the shells are not filling up in order. First shell, second shell, third shell, fourth shell, back to the third shell, and now out to the fourth shell again. If you're saying to yourself, I'll never remember all this, be aware that there's going to be a pattern that you should see kicking in, and if it makes you feel any better, most classes, including my own, allow people to use the periodic table to determine electron configuration. It's almost like a cheat sheet, if you will. Let's continue with the fifth shell. We are now at 5s2, and if we continue out to cadmium, atomic number 48, we are now starting to populate the fourth shell, 4d10. Bringing us out to xenon, it's now 5p6. I'll very quickly say the entire electron configuration of xenon. No big deal, just read it. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p6. Since it always follows the same pattern over and over again, the simplest way to say it is that the electron configuration of xenon ends in 5p6. Getting larger, we go out to 6s2. Then I'm sure you could continue, or maybe you notice there's something weird going on here. I was about to say 5d10, but I'm noticing these little red lines, and that's simply it's simply that this should be here, but they decided not to for reasons of the shape of the periodic table. You see these two long rows here? They're supposed to go right there and right there respectively, because we went down one shell when we went from 4s to 3d. When we go from 6s, we're now going to go down 2 shells, from 6s to 4f. We are now in a orbital group that has not 2, not 6, not 10 electrons, but 14. And going out to ytterbium then brings us to 4F14. Where do we go next? Well, this was element 57. And there's 70. Now we go right back to there. So these little red lines are designed to help you. Every periodic table does this. And so realize that this is just just to make it a little bit less wide. So after 4F14 goes 5D10. I'm just going to continue all the way through so that, to save a little time. 6P6, 7S2. I do not say 6D10 because we have to drop down to element number 89 at this point. That must have been 88 there. And so after 7S2, 5F14, then 6D10, 7P6, and that brings us out to the end of the known universe. Now, that's oganescent at this point. These ones have all been named at this point in time, 2018, and this is a pattern. It's a symmetrical pattern. If you really understand it, you should be able to determine the electron configuration of element 119, which may be discovered soon. So in the next slide, we'll continue this pattern to show you that it's infinite. Our conclusion for now is that the periodic table is based on the aufbau order, which is the electron configuration going from the inner shells to the outer shell, and it's a powerful tool.